If you've ever been to an air show or even ridden on a plane, you know that when a plane turns, it actually banks, right? It lowers the inside wing higher than the outside wing as it makes a turn. And now we'll look at the reason for that, and it involves circular motion. So the plane is, of course, going to have a force of gravity acting down on it. But to keep it in the air, there's also another force upwards, which is the lift. And so this is caused by the wings, and it's actually what keeps the plane flying in the air. And so it's just going to act upwards to counter gravity from the plane. Okay, but now let's imagine that we have a plane, and it's undergoing circular motion with some radius r. Okay, so we want to make a turn, and we're going to have some turning radius. So we know that in order to have uniform acceleration, to have uniform circular motion, there has to be some acceleration pointed inwards. Well, if we look at the forces, here on the plane, we don't see anything that's going inwards. So the way that we do that then is that's why we tilt the plane. So now the lift is coming up from the wings, and it's pushing it upwards to the plane, which is actually up and to the left. Because recall, we still have gravity acting straight down. And now this lift is going to be making some angle theta with a vertical. So it means that our net force is going to be minus the lift, sine theta, in the x direction, and the lift, cosine theta, in the y direction, 0 minus me minus mg, and that's going to equal the mass of the plane times the acceleration. Okay, so depending on what the lift is, it's possible that you could be turning and also falling down at the same time, or even turning and moving up at the same time. You're not necessarily going to be moving in exactly a parallel line. But notice what this tells us for our F net. Let's say that we have a lift that's at such a magnitude that with the lift in theta, we only have an inward acceleration. Well, that means that our F net now is going to be to the inside, and so this is going to be the acceleration, m times a, that turns the plane. So we see that our acceleration can just be written as a is equal to 1 over m minus the lift force sine theta, and the lift times cosine theta minus mg in the y direction. Okay, and of course this is only at this instance, right? When a is going to the inside. In general, this is just talking about this first term here is just the radial term, right? This is just telling us the magnitude of the acceleration toward the inside. And so this is how a plane turns, and this is now we're seeing kind of a different application of using circular motion in a problem.